Okay, for the second part I want to make sure we cover here is the difference between increase and decrease. Alright, so in this example, I've got a graph where one is increasing on the left and the other one is going to the right, or a function that is increasing and decreasing. So in this case, they're just inverses of each other, but it's easy to compare them. So the first thing you do when you're given random values, and it's not set, is you want to compare them. First we need to see if they're linear or if they're exponential. Alright, so in this case, I'm suspicious just looking at it, is that it's going to be exponential because it's doubling every single time. The other one is reducing every single time. So once we have our values, then we can find everything else. So we test that in, and first we use, for linear, we take 2 points, 2 pairs of points, y2 minus y1, m2 minus m1. We plug that value in, and we see if it works. If that works, then we plug in the values. So if it doesn't work, if they don't match, then we move on to exponential. Exponential is x2 minus x1, which is the root y2 over y1. Right? So we're going to use that, and we're going to compare 2 points. If they match, then we know it's exponential. All right? If it's neither one works, then we just plug it in. So in this case, we do our first one. So up here at the top, like I said, we know if we plug in those points, we're not going to get there. So we go to our first one here. So we get 32 minus 16, which is 16 over 1. So it's 16. Here we go 64 minus 32 is 32 and 1. So these two do not equal each other. So I know that it's not going to work. If we do the same thing over here, our values, we end up with negative 8 over 1, and we end up with negative 4 over 1. Still doesn't work, so we know they're not equal. So we know it's not linear. All right, so if we take those same values, we move it here, and what I've done is I've just put them side by side. One thing you want to be careful of, so you guys remember I got thrown off on Wednesday, and it was something very simple. Instead of taking the y2 over y1 here, I flipped the y1 and the y2, which caused me all sorts of nightmares because I couldn't figure out why my numbers were off. It turned out it was a simple step 1 mistake. I flipped my ordered pairs backwards, which gave me an answer I couldn't get. All right, so let's see if we get the same here. So we have our values here. So this is going to be 1, and this is 32 over 16 is going to be 2 over 1, which is just going to be 2. We do the other value, we get 1 and 2, which equals 2. Anything to the first root is 2. So we know it's exponential. We don't have to go any farther with it. All right. When we look at the other side, we end up with 1 and 1/2, right, which is just 1/2, and this one is also going to come out at 1/2. All right, but it's an inverse. This is probably easiest. You can do this in fractional format. Since you guys are going to get to use a calculator, 0.5 is probably going to make your life a lot easier. All right, so for these two different ones, all right, what we're looking at is this value. This is a2 to the x. Over here, this is a2 to the x. All right, sorry, 0.5. Don't want to make that mistake again. All right, so 0.5, because this is going to be the inverse. And like I said, the other day, all I did was flip the y2 and the y1, and it caused all sorts of problems and issues. All right, so now we have our equations, but we need to find out this a value at 0. So we come back here. We don't know what it is, but we do know that this 2 was our multiplier. All right, and that means if we're going backwards the other way, we've got to take away half to get there. So 8 times 2 is 16. 4 times 2 is 8. This is 7. Well, we'll come back to that one that left it there. Here, we've flipped it, so this has to be 32 and this has to be 64. We know what that multiplier is to plug in. All right, so we have to just think logically to find that value. So we know that when x is 0, y is 4 for the first one. So now we know our equation is 4 times 2 raised to the x power. Over here, the equation, we know that f of x equals, and then, well, we got to find, we got to go look over here, so we know it's 64 times 0.5 to the x. There's our value. So again, we get those values by finding out when it's 0. Okay, if we graph this, that means the intercept's going to be 4 on the one and 64 on the other. All right, so now we can take these, and we wanted to find out 7. 7 was our missing value. So f of x equals 4 times 2 to the power 7. Over here, f of x equals 64 times 0.5 to the 7th. I'm going to plug in those values. I can't do those in my head. So again, we'll come back in here. 4 times 2 xy 7 is 512. And then the other one was 64 times 0.5 xy 7 is 0.5, which makes sense. It's going to keep going down. So we come back over to our spot here, and we know the 7 was 512, and we know that 7 on the other side was 0.5. And so it should work. We go to the 5th, should be 2, then 1, then the 7th should be 0.5. Now, the only thing you need to remember beyond that is when you talk about money, they'll talk about like appreciation. Depreciation. Or appreciate and depreciate instead of but it doesn't matter. Depreciation, appreciate. This is going up. This is going down. All right. If they say something like you started with $1,000 and you appreciate it at 8%, this would be f of x equals 1,000. And then be careful, this is appreciation, 1.08. You don't want 0.8, you want that value to go up. All right, so it's going to be 1.08, not just 0.08. It's really, 1,000 cannot decrease, it has to increase. 1,000 times 1 is 1,000, and then you're going to add that additional 0.08. So we're plugging that in, and then whatever you put in for your x value, you're going to be able to find your answers. So x, y, 0, 1, 2, 3. So you're just going to plug in and find those values. 0 is going to be 1, so it's going to be 1,000. That 1, again, we're just going to plug it into our calculations. 1,000 times 1.08 xy 1 is 10.80. Now, this basically shifted over decimal places, but we can go through to each one when we want to find our values. I'm going to do 3 real quick. So 1,000 times 1.08 xy 3, 1259.71. Depreciation, we're going to take this value here. So that starts the same. So it's the same scenario, but we're losing 8% per year or whatever the value is. The difference is this is 1 minus 0.08, which is 0.92. Okay, so it's 1 whole minus 0.08. All right, so we take away, this becomes 9, this becomes 0, and then 0.92. make sure you guys can see what I'm writing here. All right, so this is going to be 0.92 because it's 1 minus. So you've got to make that shift. So it's always 1 plus or 1 minus, whatever that value is. When we plug that in, well, we know x, y, we know 0 is still 1,000, and then at 1, it's going to be minus $92, so 1,008 1,000 times 0.92 xy1. Try that again. 1,000 times 0.92 xy1. So 920. So there's 2, there's 3, so we can complete it. 1,000 times 0.92 xy3. Alright, so if you're following all that, I'm hoping this will help you guys a little bit. The more you do it, the more sense it makes. Make sure you go the rest of it, because I may not have, like I said, there wasn't enough time to include everything we did in there, but this is going to hit the core of the different approaches. The only other thing might be patterns, and patterns you're going to break it down and just kind of look for it. Alright, so good luck to you guys. Again, I will see you on Monday and Tuesday.